Hey guys, today we are going to practice what we've done so far, and then after that we are going to start Voltaic cells. They're pretty weird, so I'm just going to introduce it today, and then on Friday we'll go over it in some more depth. Okay, so if you can open up your packet to where we left off, I believe that we're here. So there's 8 practice problems that I'd like you guys to try. I just want you to take a look at question number 8. So on question number 8, when it says, does yours say what is the total number of moles of electrons lost? They just mean what is the total number of electrons lost. So you just look at Ni to Ni plus 2 and how many electrons did it lose. Okay, so push pause, try to answer these questions, and then when you get back, what are you talking about? And then when you get back, I'll go over the answers. Okay, so in number 1, which compound does chlorine have an oxidation number of +5? So I'll do letter D. Well, I'll do A, the answer C. I'll go over how to get that though. So if I look at letter A, +1, -2. So remember, if you multiply by how many you have, you need to set that equal to 0. So since I just have 1 of each, the missing Cl would be +1. So it can't be that one. So I'm going to just try letter D, HClO4. So H is +1, there's 1 of them. O is -2, there's 4, so it would be -8. So the missing one would be +7. So it's not going to be that. Okay. Good idea. +1 times 1 is +1. -2 times 3 is -6. Equal it to 0, so Cl would be your +5 right here. So the answer is C. Okay, number 2. In which compound does oxygen have an oxidation number of -1? This is always H2O2. It's the exception for oxygen, so that's just one to know. In which compound does hydrogen have a negative oxidation number? Hydrogen will have a negative oxidation number when it combines with a metal. So the answer is A. So if I look at CaH2, Ca can only be +2. So that means H has to be negative, since there's 2 of them, would be -1. Okay, number 4, which species is reduced? So reduced means the charge goes down. So looking left to right, whose charge goes down? These are not going to be your answers. And it was Ag+, because it went from +1 to 0. Okay, next one. Number 5, the species reduced in this reaction is, it's always going to be on the left-hand side. So Sn goes from +2 to +4, so that got oxidized. Fe went from +3 to +2, so that one got reduced. So it's Fe +3 that got reduced. Okay, number 6, which species undergoes a loss of electrons? So Leo is oxidation. And remember, in oxidation, the charge goes up. So looking left to right, whose charge goes up? Magnesium goes from 0 to +2. All right, number 7, all redox reactions involve both the gain and loss of electrons. It occurs simultaneously. And then number 8, in the reaction Ni, what is the total number of electrons lost by Ni? So Ni goes to Ni +2. It's 0 here, so it had to have lost 2 electrons. Okay. on the next page in your packet, this is where this is all we're gonna do today, because it's kind of weird. Okay, so the next part is applications of redox reaction. So we actually use these a lot in real life in terms of batteries. So a battery is also called a voltaic cell or an electrochemical cell. It spontaneously converts, so this is a benefit of this application, is that it's spontaneous. So it spontaneously converts chemical energy into electricity. Okay, this little animation is pretty good, so I'll include this in your daily to-do list, but this is something you should watch. Yeah, I didn't think you liked those. Well, I'm glad you tried it. Okay, so basically what's going to happen is in a voltaic cell, you have two beakers. You have a beaker with a metal electrode that's called the anode, and a beaker with a metal cathode a metal electrode called the cathode. At the anode, you have oxidation occurring. So Zn, metal, would change into Zn plus 2 and 2 electrons. So in the bottom of this beaker, you would also have like a zinc solution, like zinc nitrate, something like that. So the zinc would get oxidized, and so it would lose 2 electrons, and the electrons flow up and around into the other beaker where you have a different electrode, a cathode, and at the cathode you have reduction occurring. So the reaction down here would be copper ions in solution change back into the copper metal. So they deposit onto the metal and it gets bigger. The salt bridge is just there to kind of connect the circuit and allow for the flow of ions back and forth. So watch the little video and it'll kind of explain what we're going to talk about in the notes. Okay, so I'm going to use some different colors as we're talking. Hey, what?
I can't even make a thing.
What? Okay. All right, so first up, let's label what we see over here. Okay, so our first metal over here, I'm going to call the anode. It does not have to be on the left-hand side. It just is the way I set it up in here, and it was the way it was in the previous animation. At the anode, oxidation occurs. And remember that oxidation is losing electrons. So the reason why there's a picture right here of an ox is an ox. At the anode, oxidation occurs. Okay, so let's label this lithium. And since it's a metal, its charge is 0. In the bottom of this beaker, you have electrolytes. And electrolytes are just moving ions that can conduct electricity. So I'm going to say that we have LiNO3. You want your electrolyte in the bottom to include the ion that's going to be made from your metal. Okay, so what's going to happen here is lithium is going to get oxidized. So lithium metal is going to change into lithium plus 1 and 1 electron. So the metal, part of it breaks off and becomes an aqueous ion. So this is going to get smaller. Okay, so as this lithium metal changes to the lithium ion, it loses an electron. And when it loses an electron, the electron flows up this way and it flows through the wire. So the wire is for electron flow. Electrons always flow from anode to the cathode. So that's how you would know what side the anode's on, because if the electrons are flowing left to right, the anode's on the left. If the electrons were flowing right to left, the electrons would be on the right. Okay, and then up here we have a voltmeter. So it's just going to measure the voltage. So electrons still going this way into our next electrode, which is called the cathode. At the cathode, reduction occurs. So that's why you have a red cat. Okay, and same thing here, you have electrolytes in the bottom of your solution. Okay, so remember, reduction is gaining electrons. Okay, so we're going to say that this is Ag metal, silver metal. Looks more like copper, but that's okay. And there's going to be Ag positives in the bottom of the solution because I'm adding the electrolyte AgNO3. And when AgNO3 is dissolved in water, it dissociates into the ions. Okay, so Ag positive is going to receive these electrons and it's going to reduce. So when it touches the metal and receives electrons, it reduces down into silver metal. So the ions in solution change back into the metal, so this gets a little bit bigger. Okay, so let's talk about the thing in the middle. And this is called the salt bridge. The salt bridge completes the circuit, allows for the flow of ions to kind of make sure charge is conserved. Okay, so let's take a peek over here. We would have something like NaNO3 in solution. And remember, when NaNO3 is in solution, since it's an electrolyte, it's going to dissociate into Na plus and NO3 minus. Okay, so over on the left-hand side for the anode, since we're going from lithium metal to lithium ion, Li0 to Li plus, we got oxidized. Your solution is going to have excess positive charges. So NO3, the anion, moves down into here to kind of make up for the extra charges that they're feeling. So NO3 minus is the anion. The anion moves into the anode. So an and an. Okay, over here, we have Ag plus is turning back into Ag0. So we're losing positive charges here. So we're going to have excess negatives from the NO3. So that means the Na is going to travel this way to make up for that lost positive charge. So Na positive is a cation. Cations move towards the cathode. Okay, so I think that's about it. Let's just kind of do like a little recap about this voltaic cell or battery, and then we will be done for today. Okay, so, and you're going to have a little homework. So at the anode, oxidation occurs. Your metal changes into an ion, and the metal becomes smaller. As the metal changes to an ion, electrons flow up, up, up through the wire to the other side. So when the ion receives the electrons on the other side, it gets reduced into the metal. So the metal gets bigger. Okay, The salt bridge permits the flow of ions, it completes the cell, and it makes up for charge. It conserves charge. Okay, so that's it for today. You're gonna have a quick homework on one of the WISER worksheets, and that'll be due tomorrow evening. Okay, so that's it. Stop share and